Welcome. In the last session, we have seen impacts of climate change that are coastal and marine ecosystem. So now in this session, we are going to see two more impacts that are ocean acidification and hypoxia, that is deoxygenation. So now we'll see one by one. So what is the ocean acidification? So when the carbon dioxide is dissolved with the seawater, it forms the carbonic acid. Thereby, there is a decrease in pH of seawater. The entire process we call it like a ocean acidification. And moreover, it is a direct consequence of excess human-induced carbon dioxide concentrations in atmosphere, right? And now, if you see, the ocean acidification is happening in parallel with the two other impacts of climate change that are ocean warming and deoxygenation. So, deoxygenation is nothing but reduction in the dissolved oxygen content in the seawater. So, when these three impacts are occur simultaneously, the combination of these three impacts we call it like a deadly trio. So when this deadly trio occurred, the combined impact of this deadly trio would be more severe than individual impacts, right? And present oceanic acidification occurs approximately 10 times faster than anything experienced during the last 300 million years. And it also uh, it also reduce and risks the ability of ocean system to adapt the changes in the ocean caused by global I mean climate change or increased carbon dioxide concentration or whatever, right? And if you see the graph, this is a global sea surface pH change. If you see the change in pH from time to time, so how drastically the pH change is reducing, that anomaly if you see, that is reducing, means pH of seawater has been drastically reduced from time to time, 1900 to 2100. These are some projections and this is as of now. So these are the some important points that what is ocean acidification and how it is. And if you see some of the impacts, ocean acidification has a lot of potential to change the marine ecosystems and also impacts many ocean related benefits to society such as coastal protection or provision for food and income, like that. And it also impacts the marine species in terms of species growth, reproduction, and structural and functional changes in ecosystem. And it can pose the great threat to the food security, harm to the fishing industry, and reduce the natural ecosystem or coastal protection. And they increase the risk of, because when there is a risk to this natural ecosystem or marine ecosystem, thereby there will be increased risk of flooding or erosion in low-lying areas, because all these uh, marine ecosystem protects the coastlines and the low-lying areas from the events called like a flooding or erosion, sea level rise and all, right? So and moreover, for survival and protection of these marine animals, generally these marine animals or organisms use calcium carbonate from seawater to build or to make their shells or skeleton, right? So what will happen when the seawater become more acidic in nature, that seawater doesn't useful or unable to make these outer hard parts or outer shells or their skeletons. And moreover, this seawater, since it's a more acidic in nature, it dissolves already whatever existing shells or skeleton, right? So because of this, the all marine animals are under a threat for survival and protection. And now, if you see, the ocean acidification is expected to cost the global economy more than 1 trillion per year by 2100. So despite there is a great risk, some of the places like small islands or low income coastal areas have no infrastructure in a place to monitor this kind of issues, right? And one of the important impact of this ocean acidification, I can say, the corals. If and that you might have seen some colorful this kind of group of species under the bottom of sea in your Discovery Channel and all. So that we call generally in a coral is nothing but actually a marine benthic animal that lives in the bottom of ocean. So they are in a symbiotic relation with photosynthetic algae, that is a zooxanthellina. So this is one of the important impact of ocean acidification, that is coral bleaching. So as I said, the coral is a marine benthic animal. So generally, in which actually it depends on the photosynthetic algae called zooxanthellina for food. Generally, the photosynthetic algae zooxanthellina lives in the coral tissues to provide the food by the process called the by the process called the photosynthesis. So You have to understand that Zooxanthellae is a photosynthetic algae. It lives in the tissues of corals, and this Zooxanthellae prepares the food by the process of photosynthesis, right? Thereby you can get the the corals can get the food. So whenever the possible conditions are not there in the ocean water, like sufficient sunlight or sufficient warming, so then automatically the photosynthetic algae zooxanthellae will expel from the tissues of the coral. Thereby there will be no food at all for the coral, so corals will be starving thereby, and can sustain for a while, like 1 week or 10 days. Then if still that photosynthetic algae do not enter into their tissues to prepare food for them, then eventually they will die. So this is the entire process we call generally coral bleaching. Because of this excess ocean warming and ocean acidification, there is no more the zooxanthellae or photosynthetic algae in their tissues are staying there because of this non-favorable conditions in the ocean water. So they are expelling that coral polyps. Then thereby corals will be like starving continuously, and then eventually they are dying. The process we call like a coral bleaching, right? So when the coral got dyed or coral got bleached, that you can see in this images like white in color. So this is the process called the coral bleaching. So there are massive coral bleaching events occurred that we can see now. And moreover, why have to worry about the coral and coral bleaching events and all? This is one of the highest biodiversity of any ecosystem globally, and provides goods and services with a value of at least $30 billion for a year, and moreover supports at least 500 million people worldwide. Okay, and this is one of the, as of now, because of this impacts of global climate change, this is one of the most threatened ecosystem on the earth, largely due to climate change or whatever, because of increasing global warming, ocean warming and acidification and combined effect, like that. And according to the UNESCO, the coral reefs in all 29 reefs containing World Heritage Sites would cease to exist by the end of this century. So how much impact is the ocean acidification and ocean warming impact on these coral reefs or coral reef sites and all? You can see it's going to be the 29 reef containing World Heritage Sites are going to be seized by the end of this century if we continue the emissions like this, right? And of course there are a lot of coral diseases in southeastern Florida in 2014, and widespread mass bleaching events of the Great Barrier Reef in Australia. And see this kind of massive bleaching events occurred in 1998, 2002, 2016, 17, 2020, and now recently in 2022 under the La Nina conditions as well. And nearly 60% of the individual reefs coral had bleached by the coral got bleached by this ocean warming and ocean acidification events. This is a report from the Great Barrier Reef Marine Park Authority. So in this process, I mean, how the climate change impacts the corals and all. What are the possible, uh, I mean, uh, favorable conditions to um, sustain the corals in marine water and all? You can see in this from image in a clear, detailed manner, right? This is one instance of the coral bleaching at a Scott Reef in April 2016. Okay, this is a possible impacts. Then what kind of remedial measures that we have to take to control this? So ocean acidification international reference user group, OARG, examines generally in detail types of data and analysis and products that are useful to managers, policy advisors, decision makers and politicians, and to ensure that appropriate format and distribution pathways to control all this. And sustainable management, of course, conservation, restoration of this ocean, everything is needed. Otherwise yeah, the effects will be more severe. So at the IUCN World Conservation Congress 2016, the IUCN members approved that resolution calling for the protection of 30% of the planet's ocean by 2030. So these are the agreements, commitments that we have to take to control these impacts of this ocean acidification and warming and combined effect, like that. So of course there is this is a common remedy that we have to follow for every impact of climate change, that we have to reduce the average global average temperatures to well below the well below 2 degrees Celsius above the pre-industrial levels, of course, according to this Paris Agreement. And investment should also come with, should also support for research at the frontiers of biology to generate genetic selection of this heat resistant corals. Means now the corals are unable to sustain in the heat, more heat. When there is a more heat, the coral will not sustain in that. So we have to encourage the scientists for the biology and all to create the genetic selection of the heat resistant corals, so that can withstand with the rising temperatures, rising global temperatures and all, right? So if you see this, this is the some statistics from the IPCC, like coral reefs, when there is increase in temperature of 1.5 degrees Celsius, what will be the impact? And similarly 2 degrees, and similarly 3 and 1.5 or versus 2 degrees, what would be the impact and all, you can see, right? And coming to the another process called impact of climate change, called like hypoxia. So this is the deoxygenation. As I said before, that this is a process. Deoxygenation is a process in which reduction of the dissolved oxygen content in the ocean. So it is primarily caused by the ocean warming and eutrophication. Eutrophication is nothing but excess growth of the algae. So when there is a huge amount of the nutrients that we are releasing from the coast because of so-called frost and all, when there is a huge nutrient, that there will be a huge production, biomass production, right? So this huge production and the ocean warming combinedly forms the process called like oxygen reduction in the dissolved oxygen content in the ocean. That's what we call like ocean deoxygenation, right? You can see. So the why we have to study, because even small reductions in the dissolved oxygen levels in the ocean can trigger the oxygen stress in a marine life by losing the adequate supply of oxygen at a tissue level. This process, that's why we call it like a hypoxia. We also name these wherever this low oxygen levels in the ocean, those zones we call like ocean dead zones or oxygen minimum zones we call. And worldwide, the oceans have lost about 2% of the dissolved oxygen since 1950, and it is expected to raise that same loss of oxygen 3 to 4% by 2100. So most of the oxygen loss in the oceans, oxygen loss in the ocean concentrated within the upper 1000 meters, where are the species abundance is very high, right? So these are the possible points that we can say deoxygenation is happening in the ocean. So what kind of impacts that we get? If you see, so so far this image tells you that how much amount of the oxygen got reduced, what are the possible reasons uh, that deoxygenation is, what are the possible causes that creates the deoxygenation in the oceans, like ocean warming, stratification, cultural eutrophication, enhanced eutrophication, that's all. This kind of process will form the deoxygenation. So stratification is nothing but reduction in the ventilation process. If you see last image, so there reduced deep ventilation. There is no when the stratification is increased, there is no sufficient or strong mixing. Thereby, there you cannot get surface oxygen rich water doesn't mix with the deep water. That's why there is a reduced ventilation because of the enhanced stratification and all. So these possible reasons cause the deoxygenation in the seawater, right? And now if you see, the ocean represents around 97% of the physical habitable space on the planet. So we have to take care of it, like to protect mostly on the marine life in the ocean, right? So of course, we know that loss of oxygen from the ocean will have severe impacts on the marine biodiversity and functioning of ocean ecosystem. And the deoxygenation process has started to alter the balance of marine life. Means kind of whatever what I can say, hypoxia tolerant species, means a kind of species that can tolerate even low oxygen waters as well, like such as the microbes, jellyfish, and some squid, and at the expense of hypoxia sensitive ones, means the species which cannot tolerate in the low oxygen water. Okay, the water where you can see the very low oxygen content. So this kind of animals like tuna, marlin, swordfish, and sharks, these kind of species cannot tolerate in the low oxygen content of the ocean water. So this kind of alterations are going on by the process of this deoxygenation. And the degraded habits can lead to the reduced catch for the fisheries, and thereby you can see some regional stocks are likely to collapse. So where there is a less in the fish catching and all, the regional stocks obviously so-called reasons of there is likely to collapse because it changes, the effects are like that much impact. And this change in the distribution of species can also significant negative socio-economic and health impacts, right? So when there is a change in distribution of species and all, that definitely there is an adverse effect on all the local or regional community and fisheries, whatever impacts. So this kind of, it can create the negative socio-economic and health impacts. So this much impact is going to be created by the process called this deoxygenation. So, and it also influences the movement of the gases between the ocean and the atmosphere. So because of this is a reduction in the gases of the ocean. So there is so thereby you can see some different movement of the gases between the ocean and the atmosphere as well. If it is increased a lot and lot. So these are some of the sites where the coastal hypoxia, where the ocean oxygen, dissolved oxygen is less than 2 milligram per liter. If you see some of the dark indicates the coastal hypoxic sites, and so blue and black indicates the accordingly the oxygen reduction from the liter. If the oxygen, see blue, light blue, when the oxygen is less than 2 milligram per liter, and medium blue when oxygen is 0 point less than 0.7 milligram per liter. Similarly, black oxygen is less than 0.07 milligram per liter. So these are the some coastal and open ocean regions where you can see oxygen reductions, oxygen content, dissolved oxygen content in the oceans are very less. And we have to see what we have to do that. So of course people, industries, governments, everybody must reduce the carbon dioxide emissions and marine nutrient pollution, because as I said before, so for this deoxygenation, one of the main reasons ocean warming, but also the excess nutrient releases from the coastal regions, releases into the coastal regions from so-called industries or whatever. So we have to control those carbon dioxide emissions and all, and marine nutrient pollution, right, to reduce the oxygen loss. And of course nutrients emitted from the like agriculture, from treated and untreated wastewater to means from these fields like agriculture, from all the treated and untreated wastewater, the nutrients are going to be like a major contribute to the oxygen depletion in coastal waters, right? By enhancing, as I told, like enhancing the water like with the rich nutrients, right? So and of course some of the solutions to reduce the nutrient runoff, like effective nutrient reduction strategies including introducing the legislation to limit, we have to set some kind of limits to release the nutrients into the coastal regions from so-called industries like agriculture, whatever. And we have to set some specific goals, and we have to put some monitoring uh, uh, technology to identify these problems and all. So, and of course, this is the largest oxygen loss observed at the depth of around 100 to 300 meters in the tropical and North Pacific, Southern Arctic, and South Atlantic oceans, right? So, in such a way, we can reduce somehow and control this deoxygenation process in the oceans by as an impact of as an impact of climate change, right? Okay.